Welcome to the Deep Dive. Our mission today is exploring how we can use technology to actually solve that crushing complexity of modern leadership.
And we have a really fascinating stack of sources to go through today.
We do, and they all point back to the systems built by Harry Lanzett.
Now, in our previous deep dives into his work, we explored the physical side of things, right? The blue to gold nexus, that massive sand battery producing clean water and energy.
Yeah, and we also looked at his Hephaestus macroeconomic simulator.
Right. But looking at that sheer scale of infrastructure, it reveals this massive bottleneck.
Yeah, well, the bottleneck is human biology. Because when you start operating infrastructure at the scale Lanzett proposes, the physical technology ceases to be the limiting factor. The limitation becomes, the human being sitting in the decision maker's seat.
I mean, a human simply cannot process 10,000 interconnected variables in real time.
Exactly. To find the absolute optimal and fairest outcome for a society, we just have biological limits, we get tired, our attention spans wavered, and we miss hidden complex connections in these massive data sets.
Right. You might have every intention of making the perfect choice for your community, but the ripple effects of your decision are literally beyond human comprehension.
Which is where today's topic comes in.
Right. Which brings us to the core of our deep dive today. I went through the source material, and I found Harry Lanzett's public GitHub showroom.
The Sampo AI OS.
Yes, it's an organization called Sampo AI OS, and we're going to look specifically at how two of its components, a repository called Ethics and another called the DAO Ethics Engine, act as this intelligent, objective decision support system.
Because expecting a leader to manually process global infrastructure variables to find the perfect policy, it's just not going to work.
It's like asking someone to predict a hurricane using an abacus. It's an entirely unfair expectation.
It really is. And to understand the support system, we have to look at the architecture of the showroom itself. The Sampo AI OS GitHub organization, it operates as this autonomous solution factory.
Right.
If you browse the public footprint, there are 16 public repositories. And what stands out immediately is the naming convention. Most of them start with the letters DAO, Decentralized Autonomous Organization.
Okay, so for those trying to visualize this, think of a DAO as a management structure that runs on software rather than, like, human hierarchy.
Exactly. And this architecture features a central orchestration layer called the DAO Hub. And that's surrounded by 11 specialized domain nodes.
The domain nodes being the specific areas of focus. So there's a node for energy trading, one for supply chain auditing, another for climate governance. It's a completely interconnected digital ecosystem.
Right. But the mission of this showroom is really vital to grasp. This isn't just some passive code dump where developers store their side projects.
Oh, absolutely not.
It is an operational control surface. Lanzett is demonstrating that governance doesn't have to be a passive reporting layer.
Like the traditional model where we enact a policy, wait 6 months, and then look at a report to see what went wrong.
Exactly. In this architecture, governance is a measurable, traceable ecosystem. The decision logic is actual executable code. It's not just, vague meeting minutes from a closed-door political session.
Which is a huge structural shift. But it immediately makes me think about the real-world realities of deploying these systems today. I mean, leaders are terrified of liability.
Oh, definitely.
Specifically regarding new heavy-hitting regulations. Like the EU AI Act is a massive source of anxiety right now.
Oh, absolutely.
So how does this operational ecosystem handle highly specific, high-stakes regulatory threats?
Well, that is the exact problem the repository called Ethics OS is designed to solve.
Okay.
It's a compliance assessment platform tailored specifically for EU AI Act use cases.
So rather than handing an executive or like a software team a dense, multi-hundred-page legal document and just hoping they interpret it correctly.
This provides an actual software tool. It evaluates a structured description of an AI system against the model obligations of the EU AI Act, specifically Articles 5 and 9 through 15, which are cited in our sources.
Wow. So this shifts compliance from a retroactive audit where you build a product and then hire lawyers to tell you if it's legal into a proactive engineering discipline.
You run your system architecture through this platform on day one.
Okay, but let's play out a scenario here because this feels almost like a trap. Suppose a team runs their proposed system through the Ethics OS and the screen flashes green with a high-risk compliance score.
Okay.
Does that mean the AI is completely harmless, risk-free, and the leadership can just blindly deploy it without any further thought?
No, the documentation is incredibly strict on this point. The score is not a blanket ethical approval.
Got it.
A compliant result simply means that the specific modeled legal controls appear to be satisfied, based entirely on the data you inputted.
So it's more of a development tool.
Exactly. It outputs a risk classification, it highlights confirmed violation rules if the architecture breaks a law, and it provides, like, concrete remediation hints alongside English language compliance guidance.
It doesn't replace human scrutiny. It focuses human scrutiny on the right areas.
Yeah, exactly. And accountability is a major factor here, too. The sources highlight that the system uses tamper-evident evidence chains.
Oh, right. When it generates the certificate of compliance, that certificate comes with a deterministic SHA-256 fingerprint for offline verification.
Which is such a brilliant piece of technology.
Let's break down the mechanism of that fingerprint for the listener because it's so important.
Yeah, so a SHA-256 fingerprint is a cryptographic hash function. Think of it as a mathematical digest.
Okay.
You take a massive file, say a 500-page system architecture document detailing every variable of your AI, and you feed it into the algorithm.
And the algorithm spits out a unique 64-character string of letters and numbers.
Right, that string is the fingerprint.
But the crucial part is how sensitive that fingerprint is.
Oh, yeah.
If someone goes back into that 500-page document months later and changes a single comma or, alters one variable from a 1 to a 0 to hide a mistake,
The entire 64-character fingerprint changes completely.
it doesn't just change one letter.
No, the whole string is completely randomized. Anyone looking at the audit trail will immediately see that the document they're holding does not match the mathematical fingerprint generated on the day of approval.
It creates an unforgeable proof of state.
Exactly. It proves exactly what was approved and exactly when it was approved without requiring, like, a centralized human authority to verify it.
But that transitions us into a much deeper problem, doesn't it? The AEthics is handling strict legal compliance. It checks the letter of the law.
Right.
However, as history shows us constantly, legal does not always equal fair.
Very true.
I mean, a policy can be perfectly compliant with regulations, yet still disproportionately benefit a tiny, wealthy fraction of society while leaving the majority behind.
Yeah, so how does a digital architecture measure something as subjective as who actually benefits?
That brings us to the analytical layer of this ecosystem, the DAO Ethics Engine.
And this is where it gets incredibly cool. The DAO Ethics Engine is a specialized multi-agent governance node. And what makes this engine remarkable is that its foundation isn't a new piece of computer science.
Right.
It's actually the mathematical implementation of political philosophy, specifically the philosopher John Rawls and his concept of the veil of ignorance.
The veil of ignorance is one of the most powerful thought experiments in modern philosophy.
It really is.
For the listener, imagine you are tasked with designing the rules of a brand new society. But there is a catch.
A big catch.
You have to design these rules before you are born into this society, and you have no idea what your position in it will be.
You don't know if you will be born incredibly wealthy or destitute, perfectly healthy, or with a chronic illness.
Exactly. You don't know if you'll be born into a majority demographic or a marginalized one. So because you don't know where you will land, your own self-interest forces you to design a system that is fundamentally fair for everyone.
You ensure the safety net is strong because you might be the person who needs it.
It is a brilliant way to conceptualize fairness, but translating an abstract philosophical concept into deterministic executable code, that's a completely different challenge.
It is. But Lancet achieved this by hard-coding a fairness threshold directly into the API of the ethics engine.
And he used an economic metric known as the Gini Coefficient.
Right.
Let's spend some time on the mechanism of the Gini Coefficient, because it's really the beating heart of the ethics engine. How does a single mathematical formula measure the fairness of a complex policy?
Well, the Gini coefficient measures the inequality of a distribution. Usually that's wealth or income, but in this case, it's the distribution of a policy's benefits.
Okay.
The scale runs from 0 to 1. A Gini index of 0 represents perfect equality.
So if a policy generates $10 million of value, and every single citizen receives the exact same fraction of a penny,
Then the Gini is 0. Exactly.
Sure.
But an index of 1 represents perfect inequality. One single person gets all $10 million and everyone else gets nothing.
Okay, so a lower number means a broader, more equal distribution of the benefit.
Correct. And Lancet embedded a strict numerical constraint into the architecture. The threshold for any policy to pass through the engine is a Gini index of 0.40 or less.
Gini must be less than or equal to 0.40. And what strikes me is that this isn't like a guideline.
No, not at all.
It isn't a recommendation that a board of directors can just choose to ignore if they find it financially inconvenient.
Right.
It is an embedded mathematical constraint. It is essentially the physics of this software environment.
Yeah, protecting the least advantaged is entirely non-discretionary here.
Wow.
If a leader proposes a policy and the engine calculates that the benefits will skew heavily toward a narrow elite, pushing the Gini coefficient above 0.40, the system just flags and rejects it.
The source documentation actually provides concrete examples of this.
Yeah.
A hypothetical proposal for a corporate tax cut was fed into the engine. The system calculated the benefit distribution, returned a Gini coefficient of 0.59, and automatically rejected it for failing the fairness filter.
But then conversely, a proposal for universal healthcare was evaluated. It scored a 0.04, demonstrating a massive, broad public benefit, and the system approved it.
It really functions as an algorithmic shield for the vulnerable.
It does.
But this raises a massive logistical question for me. A strict mathematical threshold for fairness is incredible, but any output is only as reliable as its input, right?
Sure. Garbage in, garbage out.
Exactly. If a leader submits a proposal, what stops them from using heavily biased data to artificially lower the Gini score? How does the engine evaluate the evidence behind these proposals without human biases sneaking in and skewing the math?
Well, that vulnerability is addressed by the multi-agent nature of the DAO Ethics Engine.
Okay.
The system doesn't just rely on a single linear calculation. It relies on multi-agent consensus simulation.
Let's break down how that actually works. What are these agents doing?
So the system utilizes multiple synthetic AI agents, and they act independently to review the evidence attached to a proposal. They aren't taking a simple majority vote, like a group of executives raising hands in a boardroom. They are using highly complex mathematical algorithms to reach a grounded agreement about the validity of the data.
The sources specify algorithms like belief propagation, RAFT, and Byzantine fault-tolerant consensus.
Right.
We should define those mechanisms. Let's start with Byzantine fault-tolerant, or BFT. In computer science, a Byzantine fault refers to a scenario where different nodes in a system might fail, or worse, they might transmit conflicting or false information.
Which happens all the time in complex networks.
Yeah, so a BFT system is designed to reach a reliable, true conclusion, even if a certain percentage of the network is actively transmitting bad data or compromised. It mathematically forces consensus out of chaos.
And then you have belief propagation, which is an algorithm used to calculate probabilities across a complex network of variables. The agents use these methods to basically stress test the underlying data of a policy.
But the sources also state that the system automatically identifies human cognitive biases, things like confirmation bias, anchoring bias, and status quo bias. But how does code detect human psychology? Code can't read a politician's mind.
No, it doesn't read minds. It reads statistical fragility.
Oh, that's interesting.
The system algorithms use explicit metrics to score the quality of the evidence. It looks at the sample size, the statistical confidence thresholds, and the variance against historical baselines.
So, for instance, if a proposal claims a massive public benefit, which would artificially lower the Gini score to pass the threshold, but the synthetic agents see that the underlying data relies on a survey of only 50 people with a massive margin of error,
The system flags that.
it uses that statistical weakness as a proxy for cognitive bias.
Exactly.
It recognizes the mathematical signature of someone cherry-picking a tiny data set to justify a predetermined conclusion, which is the definition of confirmation bias.
Right. Weak evidence results in automatic rejection. And think about how transformative this is for decision support.
It changes everything.
In a traditional setting, leaders will spend months locked in endless debates over whether a data set is robust enough to justify, say, a multi-billion-dollar infrastructure project.
Personalities clash, political pressures mount, and subjective opinions blur the facts.
But in this architecture, that entire subjective debate is removed. It acts as an impartial algorithmic safety net.
This system provides the mathematical reality of the evidence.
Exactly. If the data is weak, the policy dies at the proposal stage. Decisions are forced to be based on rigorous statistics, demonstrable public benefit, and explicit numerical constants.
It fundamentally changes the role of the human leader. The leader is freed from the agonizing cognitive load of weighing impossible interconnected variables.
They can actually focus on high-level strategy, vision, and human empathy.
Right. Knowing that the tactical execution of their ideas is strictly bounded by mathematical fairness and legal compliance.
It's a huge relief.
Let's step back and look at the synthesis of everything we've just discussed. Harry Lancet took an abstract concept of political philosophy, the veil of ignorance. He took the dense punitive reality of regulatory compliance, the EU AI Act, and he took incredibly complex multi-agent consensus mechanisms.
And he wove them all together into executable, open-source APIs.
He built an ecosystem that genuinely assists institutions in making better, more objective, and fundamentally fairer decisions.
It represents a profound shift in our approach to governance. It moves ethics and fairness out of the realm of theoretical debate and turns them into structural engineering requirements.
You can no longer just promise to be fair.
No, You have to prove it mathematically before the code will even compile.
But the truly staggering part is that we have barely scratched the surface of the Sampo AI OS showroom today.
Oh, not even close.
We only explored 2 repositories out of the 16 sitting publicly on GitHub. When you look at the names of the others repositories like DAO Quantum Identity and DAO Digital Twin Bridge, you realize the scale of the digital infrastructure being proposed here is immense.
The ecosystem is vast. And the connections between these domain nodes hold the potential to redefine how global resources are managed.
We will definitely be opening another door in that showroom in a future deep dive. But as we wrap up today, I want you to think back to that impossible control panel with 10,000 dials we talked about at the beginning.
Yeah.
If the sheer complexity of the modern world has surpassed the limits of the human brain, we have to rely on systems like this to help us steer the ship.
Which leaves you with a final provocative thought to ponder. We have just explored how it is entirely possible to encode philosophical fairness and strict legal compliance into deterministic algorithms. We can mandate a Gini coefficient to protect the vulnerable in a digital ecosystem.
Right?
If this mathematical approach to fairness proves to be consistently more objective, more reliable, and less prone to bias than human intuition, could it eventually replace the subjective, human-run legal systems we currently rely on to govern our physical societies?
Are we just looking at an incredible decision support tool for today's leaders, or are we looking at the underlying blueprints for the future of justice itself? Something to mull over until next time. Thanks for joining us on the Deep Dive.